Much for me, much for you, that. Look how hard me I work, oh God. Now feel much me work so hard. Confident out there now, one straight A's now. Much in my world, my world.
Hello students, welcome to another class. I am your usual guide, Ken Roy, and today we will be talking about equations. We will be using them to illustrate some word problems. Here are our objectives for this class. First, we will look back on the idea of expressions. Then the link will be made from an expression to an equation. Once we have established what an equation is, we will then look at word problems. Finally, we will use equations to illustrate these word problems. Did you make note of our objectives? If you did not do so now. Okay, let us proceed. This is Mr. Owl. He'll be asking you some questions at different points in this lesson. Pay careful attention so you do not miss what he asked. For his first question, did you say a statement or a part of a sentence? In English, yes. This is a great way to look at it so you can understand it better mathematically. What do you say a mathematical expression is? Did you say a numerical statement? For example, 5. What about a part of a number sentence? Like 5 added to x. Both of these can be considered expressions. They convey information but not the complete idea. Can you think of any more expressions? Let us consider our last numerical statement. That is 5 added to x. Recall that x is just used to represent an unknown number. So it is possible to know what it is, but first we need to know the complete idea being communicated. Okay, Mr. Owl. Did you hear what Mr. Owl said? If 5 added to x is 9, it is now possible to tell what x is representing. We now have a complete idea. How would we show this mathematically? Well, we could write it by separating the expressions using an equal sign. That is, we could consider this an equation. 5 added to x is 9. Great question, Mr. Owl. How is an equation different from an expression? How about listing those differences, namely those we see in this equation? Yes, the equation has an equal sign. Yes, the equation expresses a complete idea, not just part of an idea. In other words, it is a complete statement, a mathematical sentence. Based on these points, can you write down an equation, what an equation is in your own words? Nice. Go ahead and do so. Let us see if our definitions match. We can say that an equation is a mathematical sentence. It tells us that two quantities or expressions are equal. Here are some examples. When 6 added to 7, the sum is 13. If we subtract 6 from 45, the difference is 39. 8 multiplied 9 is 72. 48 divided by 8 is equal to 6. Our examples are complete ideas, sentences. These tells us the relationship among each of these number pairs. They are all equations. Some problems do not appear in the form of numbers. When this happens, how do we treat it? Well, consider these scenarios and feel free to try them on your own before we do them together. Scenario 1. Joy and Mark purchased some masks. Joy bought 7 and Mark bought 4. How many did they buy altogether? Scenario 2. In this scenario, Craig stacked some shelves. he managed to fill 4 rows with 12 bottles in each row. What is the number of Lysol bottles on the shelf? Scenario 3. To make breakfast, eggs from a flat containing 30 was used. From the flat, 2 were used for pancakes and 4 were scrambled. What is the number of eggs remaining? Scenario 4. The line outside a supermarket is made on the walkway 24 feet long. Customers are instructed to stand 3 feet apart while waiting in the line. If the line is currently full, what is the number of customers waiting in that line? Great question, Mr. Owl. What was your response to Mr. Owl's question? Did you say yes? Great. We will now see how powerful equations can be. I know some of you already know the answers for the scenarios posed, so let us now see how we can, by use of equations, show how you got those answers. Scenario 1. Joy and Mark purchased some masks. Joy bought 7 and Mark bought 4. How many did they buy altogether? First, let us identify the quantities in our problem and the context in which they were stated. Joy purchased 7 masks and Mark purchased 4 masks. That is 7 and 4. In total, this would be 11. 7 added to 4 is 11. Did you get this sum? Great. On to scenario 2. In this scenario, Craig stacked some shelves. He managed to fill 4 rows with 12 bottles in each row. What is the number of Lysol bottles on the shelf? First, let us identify the quantities in our problem and the context in which they are stated. Craig stacked a shelf with 4 rows having 12 bottles in each row. That is 4 groups of 12. 4 groups of 12 is 48. 48 bottles of Lysol. Did you get the same number of bottles? Awesome. Let us now consider scenario 3. To make breakfast, a flat of eggs containing 30 was used. From that flat, 2 were used for pancakes and 4 were scrambled. What is the number of eggs remaining in the flat? First, let us identify the quantities in our problem and the context in which they are stated. The flat of eggs contains 30. 2 was removed for pancakes, then 4 more were removed and scrambled. This would make the problem 30 minus 2 minus 4 more, or if you want to say 30 subtract 6, that's fine. 24 eggs would be left in the tray. Did you also get 24 eggs? Great job. Keep it up. Now for our last scenario. The line outside a supermarket is made on the walkway, which is 24 feet long. Customers are instructed to stand 3 feet apart while waiting in the line. If the line is currently full, how many customers are waiting in line? First, let us identify the quantities in our problem and the context in which they are stated. The walkway is 24 feet long. Customers should be 3 feet apart from each other. Yes, that is a question, Mr. Owl. How many 3 feet distances can we get from 24 feet? Well, to figure this out, we would have to say 24 feet divided by 3 feet. 24 feet divided by 3 feet is 8. There are 8 spaces available, so 8 customers are in line, given that the line is full. Is that the number of customers you got as well? Awesome. This is how we use equations to illustrate word problems. And you saw too that this skill goes a far way in helping us to figure out the answers that we need as well. Can you recall all that we did in this session? Well, in this session, we were concerned with first knowing the differences between expressions, and equations. We saw that an equation is a complete thought, and an expression, while it is a thought, it is not complete. An equation looks a little bit different, having an equal sign. It simply expresses the relationship between two or more quantities. We then use the idea of an equation to show quantities and their relationships when we express them in worded problems. In illustrating a worded problem by way of an equation, the first thing to do after reading and understanding the problem is to identify the quantities and the contexts in which they are stated. Once that is done, we are able to illustrate and eventually solve problems. Well, that is it for this session. Until next time, keep practicing.
Maths are for me, maths are for you. That. Look how hard